Everyone, today I am going to tell you about molality and molarity. These sound very similar. So then what is the difference between them? Molarity and molality. They both measure concentration. Like the amount of solute dissolved in a certain amount of solution. So molarity is defined as number of moles of solute divided by liters of solution, or it can be said volume of solution in liters. And molality, it is also defined as the number of moles of solute divided by kilograms of solvent. So molarity is about liters, the amount of space something takes on, and molality is about mass, how much something weighs. But there is a most subtle difference between the two. Like always, it tricks people. Now, molarity is about liters of solution, that is solute plus solvent. Solute plus solvent, whereas molality, it is only about the mass of the solvent. Now, let me make it more clear now. For example, we'll take 1 mole of potassium permanganate, which is equal to 158.03 grams. Okay, or you can take, it is how, or actually I'll do this and I'll show you where the difference comes in. I'll go to the scale and I'll measure 158 grams of potassium permanganate in this. That's it here. You can see I have measured 158.03 grams of potassium permanganate. I'll take this volumetric flask. It's measured 1000 ml. You can see here. It is marked here. I'll take all the contents and empty it into this volumetric flask. At the bottom, now what I'll do is add little bit of water, and swirl it till all of the KMnO₄ gets dissolved into it. Now I'll take more water, add to it and swirl it yet again till all of the contents are properly mixed into it. Now I'll add more water into the flask right up until I get to the 1 liter mark. You can see the mark, you can see the level. Can you see the level? Yeah, it's not done here. So this what I have made is 1 molar KMnO₄ solution. 1 molar potassium permanganate solution. Now yet again I'll go to the scale. I'll measure the same amount of potassium permanganate. Here I have yet again measured 158 grams of potassium permanganate, and but instead of emptying the contents into this flask, what I'll do is I'll go to the scale yet again, measure 1 kilograms of water. Start. Again I went to the measuring scale and I weighed 158 grams of potassium permanganate, but instead of directly adding it into the volumetric flask, what I'll do is I'll measure 1 kilograms of water on the scale first. Either I can take it in a flask or I can take it in a beaker. Anything can be used to measure 1000 ml of 1000 grams of water. But then instead of putting the potassium permanganate directly into the flask, what I'll do is I'll weigh 1 kilograms of water directly and then I will dump the potassium permanganate into it. Right. Now here I have measured 1 kilograms of water. Either you can take a flask, volumetric flask, or you can measure it directly in a beaker. Here I have taken a flask. I have measured 1 kilograms of water. Now I'll take this KMnO₄ and add it in this water. Now what I have prepared here is 1 molal solution of potassium permanganate. I'll mix it. I have added to it and I'll just simply mix it together. You can see here, it doesn't matter whether I have added 1 liter or not. So now here you have 1 molal solution. So the point is, here I mixed this solute and solvent together in making 1 molar solution, but here I only added the solute and I took. So the point is, here I mixed the solute and the solvent together and then I increased the volume of both of them together until it gets to 1 liter. Whereas in this I use the solute separately and solvent separately, and then I mix them together without caring for the 1 liter mark. Molarity and molality, they will remain the same when solvent used is water, because 1 liter of water will be equal to 1 kilograms of water. But if the solvents used are different, like kerosene, oil, acetone, then liters and kgs are different. Like for example, 1 kilograms of oil will be 1.1 liters of water. Thank you for watching. Till then, subscribe and keep learning.